Good day all of you. In today's video, I am going to explain set theory. Set theory. What is the importance of set theory in random variables and stochastic process subject? See, I already explained in my previous video that randomness of the random signal is measured with the help of probability. Okay, randomness is measured with the help of probability. Okay, so we must know the concepts of probability. To understand the concepts of probability, we must know set theory because the operations in probability are very similar to the operations in sets. Okay, now in this set theory, totally I am going to handle three concepts. The three concepts are set and different types of sets, and set operations or operations on sets, and third one, algebra of sets. Algebra of sets. Okay, so let us start set and types of sets. What is set? Set is a collection of objects. Set is collection of objects. These objects are called elements of sets. Elements of set. The set representation is like this: A epsilon A. What is A here? A is set and this small a is element. Small a is element. Suppose, take some examples. Set of chairs. Set of voltages in a circuit, set of aeroplanes, like this. You can take the examples. Okay. So here in the set of chairs are elements, voltages are elements, here aeroplanes are elements. Okay, so this is the definition of set and the examples of set. Types of sets. The first one is countable and uncountable set. Countable and uncountable set. Okay. So what is countable set? If you can count the number of elements in that set, like 1, 2, 3, etc., it is called countable set. Suppose in this set of chairs, you can count those chairs as 1, 2, 3 like that. That is called countable set. In the uncountable set, we can't count the numbers. Suppose take the set of real numbers in the range 0 to 1. Suppose if that is our set, can we count the real numbers between 0 and 1? We can't, because between 0 and 1 we are going to have infinite number of real values. Okay, so that is called uncountable set. Then the next set is empty set. What is empty set? A set is said to be empty if it has no elements. If it has no elements. That set is represented like this. Okay. The symbol phi is nothing but null. Okay. So hence empty set is also called null set. Okay. So a set which has no elements is called empty set or null set. The next set is finite set. Finite set. A set is said to be finite if when you are counting the number of elements in that finite set, the count must be terminated. There must be a terminating end for that set. That is called finite set. Suppose take one example. Take this set. You can count the elements like x1, x2, x3, and at the end the count is terminating. That is called finite set. Okay, the finite set must have finite number of elements. Suppose if the set is like this, you can count the numbers but it is not terminating. This type of set is called infinite set. That is called infinite set. Then I'll see subset. Subset. What is subset? Every element of a set A, every element of set A is also an element in set B. Then we can say A is in the set B or A is subset of B. I'll represent this concept in a diagram. See the diagram. Take it as set B and this is set A. Every element of set A, this is set A, is in set B. So A is said to be in B, or A is a subset of B, that is represented by A subset of B. Okay. Then next is proper subset. Proper subset. if at least one element exists in B which is not in A, then A is a proper subset of B. Okay. At least one element exists in B which is not in A. Then A is said to be a proper subset of B. I'll represent it with a Venn diagram. Suppose take it as set B and it as set A. We have elements. Here we have this is totally your B and this is totally your A. You have elements in B which are not in A. So now A is said to be a proper subset of B. Proper subset is represented like this. Okay. Then equal sets. If two sets A and B are said to be equal, then both sets have all common elements. A and B are said to be equal sets if these two are having common elements. Okay, then suppose if these A and B are not having common elements. Then if not having common elements, then those two sets are called disjoint or mutually exclusive sets. Okay. If the two are having common elements are called equal sets. If the two are not having common elements, then the sets are called mutually exclusive sets. Next is universal set. Okay, a set which consists of all elements. Of a given system is called universal set and is denoted by the letter S. A set which consists of all elements of a given system is said to be universal set and is represented by S. For example, in the experiment of throwing a die, I'll get 6 outcomes. What are those 6 outcomes? 1, 2, 3, 4, 5, 6. Okay. Then the set is The universal set is 1, 2, 3, 4, 5, 6. This is called universal set. Suppose in throwing, means in tossing a coin, I'll get S is equal to head comma tail. Okay, so these are various sets, various types of sets. I'll just list out the types of sets: countable and uncountable set, empty set, finite set, infinite set, subset, proper set, equal sets, disjoint or mutually exclusive sets, and universal set. Okay. Now the next concept is set operations. Next concept is set operations. What are various operations that can be performed on sets? What are those operations? Equality. Second operation, difference. Third operation, union. Fourth operation, intersection. And fifth one, complement. These are various set operations: equality, difference, union, intersection, and complement. When we say the two sets are equal, already explained equal sets. The two sets A and B are said to be equal if all elements in A are present in B, or all elements in B are present in A, or simply we can say A is equal to B. Okay. Then in this case, another important thing is you can write B as a subset of A or A as a subset of B, because the elements in A and B are same. Okay. Then the difference of two sets A and B denoted by A minus B contains all the elements of A that are not present in B. Contains all elements of A that are not contained in B. That are not contained in B. That is called A minus B. Okay. Then what is union? Let it be suppose you have two sets A and B. Then union represents like this: A union B. Okay. What it represents? It represents set of all elements of A or B or both. A union B means set of all elements of A or B or both. Next, intersection. What is intersection? Intersection is denoted by, suppose if A and B are two elements, the intersection is denoted by A intersection B.
The mainly used set operations are union, intersection and complement. Okay. So now intersection. It is the set of all elements common to both A and B. Okay. Then the next one is complement. Complement is represented by, if A is a set, then its complement is represented by A bar. What is A bar? It is the set of all elements not in A. Okay, complement means set of all elements not in A. Then what is this not in A? Then while performing the complement or while finding the complement, we must need universal set. To get A bar, simply you have to go for S minus A. Then you're going to get the complement. We'll see one example for the set operations. I'll explain the operations on sets by taking one example. See this example. Find out the intersection, union and complement by taking the given 4 sets. What are given? S means universal set. A, B, C normal sets. Okay. So see here A union B. A union B means it consists of all elements present in both A and B. So 1, 3, 5, 12 are the elements in A. These are the elements in B. So if you see A union B, see here 1, 2, 3, 5, 6, 7, 8, 9, 10, 11, then 12. Same way A union C 1, 3, 4, 5, 6, 7, 8, 12. Same way your B union C. Okay. Then see intersection. A intersection B. First if you find A intersection B. See here A consists of 1, 3, 5, 12. What is B here? 2, 6, 7, 8, 9, 10, 11. We know that intersection means it consists of common elements. Are there any common elements in the sets A and B? No. So if there are no elements, then the set is represented by null set. We know it already. So that is the representation of this 5 here. Then coming to A intersection C. What are the common elements in A and C? See here the common elements are only here 1, 3 and here also 1, 3. So your A intersection C is 1, 3. Then B intersection C, the common elements are only 6, 7, 8. Fine. Then complements. I told you already how to find the complement. The complement is A bar is equal to S minus A. What is S here? S is called universal set. Fine. Yes, here S is given. It consists of integers between 1 and 12. So now A is this. Now you have to subtract A from S. So what are you going to get? Yes, I'll get 2, 4, 6, 7, 8, 9, 10, 11 because you subtracted 1, 3, 5, 12 from S. Same way you can find B bar by going for B bar equal to S minus B. Same way C bar, which is S minus C. Okay. So this is the way of finding union, intersection and complement. After the set operations, now I'll explain algebra of sets. Algebra of sets. In this concept, we're going to see various laws followed by our sets. First one is, you are all familiar with this commutative law. What is commutative law? A intersection B is equal to B intersection A, or A union B equal to B union A. This is commutative law. And the second law is distributive law. What is distributive law? A intersection B union C is equal to A intersection B union A intersection C. Same way, A union B intersection C is equal to A union B intersection A union C. Then the next law is associative law. Associative law. A union B union C is equal to A union B union C or A union B union C, like this. You can apply for intersections also. A intersection B intersection C or A intersection B intersection C. Okay. Then separately we have De Morgan's laws. What are De Morgan's laws? A union B bar is equal to A bar intersection B bar. Same way, A intersection B whole bar is equal to A bar union B bar. Okay, so this is algebra of sets. It totally contains 4 laws: commutative law, distributive law, associative law, a separate De Morgan laws. Okay. Thank you for watching this video. If you like this video, please don't forget to like, share and subscribe.